In March 2005, a site supervisor instructed 3 workers to perform touch-up work on 6 ISO tanks which were rejected by the third-party surveyor the day before. About 2 hours later, the tank operations executive received a call from the site supervisor asking him to check on the progress of the touch-up work at the 6 ISO tanks in the washing bay. So the tank operations executive proceeded to the washing bay to check on the progress of the work being carried out. When he was up at the equipment platform, he saw a pair of boots near the manhole on top of an ISO tank. He approached the tank and saw that the air blower was not in use. He looked into the ISO tank and discovered a worker lying near one end of the tank. The worker did not respond when he called out to him. So he quickly entered the ISO tank using the access ladder at the manhole and tapped the worker. The worker did not respond. He appeared to be unconscious. The worker was found holding his respirator in one hand and a wipe cloth in the other. An unlabeled container lay nearby. The tank operations executive sensed a strong smell of thinner in the air. He immediately exited the tank with the container to call for help. The site supervisor heard the tank operations executive's call and went up to the top of the ISO tank. He entered the tank and saw the worker lying unconscious near the bottom release valve. He too detected a strong smell and quickly exited the ISO tank to retrieve the oxygen resuscitator and safety harness. The site supervisor splashed water on the worker's face and administered oxygen to him using the oxygen mask attached to the resuscitator. Subsequently, he attached the safety harness onto the worker and pulled him towards the manhole for the colleagues outside to lift him out of the ISO tank. Touch-up work for ISO tanks resulted in the death of 1 worker. What went wrong? No risk assessment. Risk assessment was not conducted and the appropriate safety measure was not identified. The procedures did not identify the hazards for confined space work involving touch-up work using thinner. No mechanical ventilation. The air blower was not in use when the worker was working inside the ISO tank. Solvent vapors given off by the thinner used during the touch-up work ended up accumulating inside the ISO tank. Inhalation of the solvent vapors over time led to the worker losing consciousness. No periodic retesting of the atmosphere. Although thinner was brought into the ISO tank, periodic retesting was not carried out to confirm that the atmosphere remained safe for continued work. No personal gas detector. The worker was not equipped with a personal gas detector for continued monitoring of organic vapors while he was inside the ISO tank. He was therefore unaware of the buildup of solvent vapors in his work environment as he continued with the touch-up work. No confined space attendant on standby. There was no confined space attendant appointed to keep watch over the worker. The worker worked alone, and there were no other workers in the vicinity. Lack of training. The workers were not given any formal safety training in confined space work. The site supervisor, who was in charge of gas checks, did not receive any formal training in workplace safety and health. He did not attend the Confined Space Safety Assessor course. The site supervisor was therefore not in the position to authorize tank entry or certify any confined space safe for entry. No hazard communication. The company did not have a copy of the chemical safety data sheet for the washing bay workers who used the thinner. The container used was not labeled. Workers were not aware of the toxic property of the chemical used. Slow in emergency response. Emergency response equipment, which includes 2 safety harnesses, an oxygen resuscitator, and a set of self-contained breathing apparatus, were not kept at the work area and immediately ready for use. This caused a delay in the emergency rescue operation. Lessons learned. Risk assessment. Before starting any work in a confined space, always conduct a risk assessment to identify safety and health hazards. Measures to minimize risks should be implemented before starting work. Mechanical ventilation. Mechanical ventilation must be provided both during work in a confined space and during rescue operation. Continuous ventilation will serve to maintain the confined space atmosphere safe for continuous work or rescuer entry. Periodic testing of atmosphere. Subsequent to initial atmosphere testing, periodic retesting must be carried out to ensure that the oxygen gas, flammable gas, and toxic gas readings remained within the acceptable limits. Personal gas detector. Even when the confined space is tested and certified safe for entry, workers should be equipped with a personal gas detector for continuous monitoring and timely alert of any changes to the work environment. Confined space attendant. An attendant should always be appointed to keep watch over any worker working in a confined space. Duties of the confined space attendant include maintaining contact with the worker inside the confined space, assisting the worker to evacuate should the need arise, alerting the rescue personnel to activate the rescue operation in an emergency. Training. It is important for confined space workers to be properly trained and fully aware of the job hazards. Confined space workers should also receive training on the proper use of personal protective equipment. Those in charge of gas checks must pass the Confined Space Safety Assessor course. Hazard communication. All chemical containers must be properly labeled to indicate its contents, the hazards involved in its usage, and the necessary precautions. The safety data sheet of a hazardous substance should be easily accessible to all workers using the substance. The SDS should also be made readily available to medical personnel treating the injured as a result of exposure to the hazardous substance. Emergency Response Plan. A good rescue plan should have names of the designated rescue personnel available, indicate the methods of rescue to retrieve persons inside the confined space, prescribe the types and availability of equipment necessary for rescue, and provide an effective means to summon the designated rescue personnel in a timely manner. Rescue equipment should be made readily available on site to facilitate prompt emergency response.